Hey everyone. In today's video, we're going to see about the first type in AI, like self-learning AI model. Uh, it is our first session in our AI workshop. So if you are someone who's new, we're going to talk about four different types in AI, like how it is actually learning by itself. So if you go back to machine learning and thinking that it have a data with a label or without label, so it learns everything by itself. So when you go with the AI, it is completely changed the way it gets trained. So you have to teach your AI model how to learn some things which is new. It is like a baby. Like you have to feed every information to it so that it get to know about it. So it have like four different types of self learning. One is feedback. Through feedback, it learns. Like you have to feed the information for every output, if it is right or wrong. The second type, it will be we can reward it or punish the model if it giving the wrong answers. Like you can just give negative score for it, or you can just have a if else loop saying good or bad respond, like reward points that you can give. Yeah.
Yeah, I mean, like I have seen the pet trainers who feed their dog when they do something,
Yes.
uh, something like that.
Exactly. Exactly similar to that. That is like reward. It comes with a reward. So the third thing is we can just give with partial data. We can give partial data to it. So those information that it will have, like cat or dog, that information. But it should identify. It also should identify horse. So that information it won't have. So what it does is whatever the information that I have, I learn that as a cat and dog. If the information which I don't have, that I'll identify as a horse. So this is your semi self-learning AI. That is your third type. And at last, you will have the continuous learning, which is your online, continuous platforms that it happens, like time series data. You will have like data every single minute or seconds. You will receive new data. With that, it understands if anything, it identifies as anomaly. It identifies as anomaly which is not fall under the particular pattern. So it identifies as it's something going wrong and I have to react back. So this is continuous learning. So these are the types in AI, and we're going to start with feedback loop. We have Enel in the call actually. So he's part of my team, and he's very curious on AI. So he wanted to learn about AI. So hey Enel, thanks for joining the call. Let's proceed with yeah.
Thank you for having me.
Yeah.
I'm very grateful that you are sharing this knowledge with me. We'll see more of this session for the audience, and yeah,
Okay, so I hope the questions that audience have, Henel will be asking the same. If you guys have few more, you can go and ask him. We have a YouTube channel, another one, which I can give that in description. And if, even you can post the questions in comment in this video. We can just rectify or clear the doubts in next session. So yeah. So the feedback loops, as I said, we feed the information for every output. Every output in the sense, good, right and wrong outputs. If it is right, we will be giving the feedback. It is right, or the ratings we can give, or any points that we can give. And if it is wrong, we have to feed the actual information to it so that it will learn from it. So that is how they build the AI agents and all. So feedback loop is one among the Q&A bots that they use it for. So here we have like several types of feedbacks. One is your positive feedback and negative feedback. So positive feedback will be used under certain use cases, and similar to, same as in negative feedbacks. So let's see only the logic, the basic logic that we have in feedback loop. What is it? We can just give a simple points to it. This is a basic structure for any feedback that you give. Uh, just give a functions that we declare as initial value. If it goes beyond that or below that, or if it is behaving somewhere a wrong direction, we have to feed the information to the model so it learns from it. Oh, okay, I'm going out of the line, out of the boundary, or crossing the way of something which is initiated within me. So I have to like fine tune it and get back to the initial stage. So this is like basic structure for any feedback session that we have. So yeah, do you have any questions or concerns on this? You know,
Not
yeah.
yeah, yeah. Not at this point. You can continue. So this is the first type of feedback learning that we are seeing, the very basic one, which is called feedback loop.
Yes. So this is the basic structure for anything that you proceed with, it may be positive or negative. This is a basic structure. I mean, you get the response, right? So you get the output and you get the input from it. So it is like interactive session that we need to design. So this is like basic. Yeah, I'll give like few examples with positive and negative session, and we'll have like one proper, real time demo or simple model that we will build so that it will be useful for us to continue with the feedback loops. Correct. So, yeah. Input is the initial signal that data enters the system and it processes the entire thing with the functions that we declare. And output is the one which, after the processing stage, it gives the output. This is like usual stage of the thing. Where it actually gives the intelligence is it learns from us, basically, learn from human. We have to feed the actual information, the real information. So it gets from us and it process again with the input or the data it has previously. So just learn from it. So what we have is like the input function, and for the process, we are like giving it to have some internal function it has. It may be points or it gives in a range between, it starts from here and it should end from here. So that basic function we give, and we can just have the, interactive session. So let's just have one thing. Like it starts from here. It is like random loop, and we just asked it to print on a certain way with a difference of zero point 0.5 on each. So we just gave and asked it to multiply for every input that we give, and it just gave it's just a print statement, but it just behaved in the way that we wanted. So it is like one simple print statement that we asked the model to perform. So it is just to understand the structure of feedback loop. Let's go with a positive feedback. So positive in the sense, wherever you see exponential function, like it should grow in order, like population you see, or any improvement or accuracy that you build on a model, you can have this positive feedback loop. So previously I got 60 percentage of accuracy. Now I need to have like above 60 percentage of accuracy. So that time I use positive feedback. So whenever I hit the +2 or +5 percentage more than my previous accuracy, the loop will be continuing. So I got positive response. So I'll be like doing it again. If I get below the actual percentage from the previous, so it will go and train the model again. So the accuracy will be used, the growth, the exponential growth of percentage will be used as your output. That is your feedback actually. So whenever I'm getting more of what I previously gave, that is my positive feedback. So let's have this exponential growth. They are like calculating here is a population. Whenever they are expecting a population to improve, I mean to grow for every 20 percentage they expecting it to grow. So here they just gave a function of 20 percentage growth rate they are expecting, just to have like a more economical growth or something that they are like expecting from it, so that we can sell more, we can expect more, and there'll be like a lot of requirements and demand if the population is more. So for that, they're giving this use case and they just trained a model on particular way saying, I need 20 percentage growth. It may be in a year or it may be in a month or something. That is a threshold that they have assigned, or we can just change, fine tune it. That depends on us. But they just wanted a growth rate of 20 percentage. So this is one example on positive, feedback. So year one, just got like 20 percentage of growth rate. And so in biological term, they are mentioning for reproduction. So they just mentioned organism or yes. So we can change that, or we can just have to sell my product. So I'm coming in Mumbai and I need this much growth in particular year. So I have to sell my product to 2 lakhs customers. So I launched my company in a particular place where I have like more population. I mean, more people, more than 2 lakhs. So if I have like 10 lakhs of people, minimum 2 lakhs can be possible that I can sell my product. So for that, I can use these kind of things to test the growth rate as a feedback, positive feedback loops that I can use for that. So this one is economic bubble simulation. So this is what I was saying. So price increases creates more high, yes, initial market excitement. So here is where they are talking about whenever, yeah, sorry.
Is talking about stock market. I mean, the second one.
Yeah, it is
Uh,
self reinforcement, which is like it depends on the popularity. When it is more popular, the particular brand, we can have like the more sales will happen. So it is like it is not stocks basically. So it depends on the brand. So whenever the brand is there, let's say you have Soul Store, that is one brand, clothing brand. So depends on the brand, the sales will be rated. If I'm selling the same T-shirt without the brand, people won't buy it on same price, same type or style without the brand or without any brand that I'm selling, people won't buy it. So it depends on the brand. So the growth rate can be calculated based on that. So these are like examples, some of the examples that we can go with positive, feedbacks. So this is one example. We have negative feedbacks also. So we'll be thinking like how we feed something which is negative, like saying it is wrong, don't go there, don't do it. So we teach kids, right? Like similar to that negative feedback. If I'm giving wrong answers, it will react in a negative way. So these are the things. And for example, if I wanted to have a room temperature in particular degree, like 22 to 25,
yeah.
so I just wanted to have it. Or if it goes above 25, it will become a room temperature. If it goes below 22, it will be very cold for me. So I just have to maintain between these range 22 to 25. So negative feedback will be helping me in such cases, saying like I should not go B. So that is my negative score. If I go above, that is my negative score. Like we can train the model to have this, to maintain the temperature according to that range. So that is one example for negative feedback. And here's the structure. I mean, the was that yes, the code.
Kind of like the program that will simulate the behavior. Let's say the room temperature is greater than some threshold, it will be a negative feedback loop. Or let's say if it is less than some temperature, then also it's a less
Yes,
negative feedback.
yes.
Oh,
So it assigned to one task, like should be in that particular stage. If it goes above or below, it will react in a negative way. That is its, feedback. So negative feedback is not in only one direction, like greater than or less than. No, sometimes it can be both, and both are wrong for that. So it have to behave in such a way to have the proper line. So that is why for that cases we will be using negative feedbacks.
correct.
Yeah. So see, here they are mentioned like essential for creating stability, like to have something stable, they'll use negative feedbacks. It should not exceed or overperform or reach the bottom.
Yes, yes. So this can
Yes.
be used also in, let's say, if we are making an auto driving car, it can be in a
Yes. Very good. Yes. Yeah, excellent. That is actually they are using. It's like a real example. Self-learning car is there, like it should not, it should not start driving when the red signal is there. So those are the traffic rules that they'll teach based on, yes,
yes. So those are predictable things, and for that we can use both positive and negative
rules.
feedbacks.
Yes, it have rules. It should follow rules. Positive means that is not the case, right? It should see something is growing or like in a positive directions, and even if it goes wrong, also that is fine. Like they can take it back. But negative in the sense like it should follow the rules. It should follow the rules. It should behave in such a way like it should not exceed or overperform. Yeah. The speed limit and all. No, no, the driving thing is a very good example. So is one, I mean, the structure is same for everything, but you have to define the function for your use cases. So the training part is same. You can use any, I mean, neural network is the constant thing that they use. And the remaining stuff are same. Like you have to define the function, like for what it have to and where it have to. So these are functions that you need to design. And the training part that any model that you are giving from the packages, it will assign and do it. So far, they are using neural networks and maybe in advanced cases for LLMs and all, they'll be using some other, recurrent neural networks that they will use. But for now, we'll try to implement a small thing. Like we're going to build a bot, not a bot, a self-learning AI, which should learn what is addition. Addition in the sense the
Some of, yeah,
sum operation. It should learn like how you will actually teach AI to learn what is addition, like summing of two numbers, how it actually do that. Let's see that in in one simple example.
correct.
Lead.
Before we not do demo, I have a small question. Let's say the regular chatbots such as ChatGPT or Gemini, that model, the model, whatever the model that they are using in backend, we fed some queries to that and it replies, and eventually it will also have something called feedback loops, right? Or so is it like is it, yeah, so is it like unified for all the users, those who are using the model, or it is like just for me?
It is actually trained one which sent to a customers, I mean the real time users. So feedback in the sense that we give feedback, yes, sometimes it gives false answers, hallucinating so many things, right?
I have
The previous version, yes, GPT-5 is the one they are saying it is having less hallucinated answers compared to older versions. So it learned from us. So those are the feedbacks. I mean, the reward, everything it has, like rewards also it has sometimes. So they can do all the combinations to build one powerful AI. So it is not they won't go with only one type of AI. It have self, semi self learning, learning also it's having, and online. I mean, continuous learning. It has feedback, reward, all together. It has self or semi self learning in the sense it has data because the internet had data, right? So they trained with it, but real time data, how a human being will talk, that data they didn't have. It has to be, sent to a user to actually have the data. So they sent it. So the real time chat GPT currently that we are using, right? It have everything all together. It is not separately having one thing.
okay.
So it has everything. If you combine all together, it will be a one powerful AI. A real-time human-based AI will have all these things in one. You're getting right. So we can't just go with only feedbacks. We can't expect a human being will be giving answers every time. No,
Yes.
and we can't just give reward every time that it gives. Like sometimes it gives wrong answer, and sometimes it gives right answer. We are not like responding back like, "Oh, okay, your answer is good." No, we are not doing that. So sometimes it have to go with the semi learning, semi self learning thing because it has data. It has to pull the data from the DB and it learns. Some continuous learning it should happen. So altogether, we are not having one type in AI.
Yes.
Yeah.
And the recently, I have also heard the news that ChatGPT has made their model open source. So, what do you think? Does that also include all the learnings of ChatGPT, what it has learned till now by the human interaction?
So maybe what I'm thinking is they learned what people we are. I mean, so they wanted wider audience, so they just give it an open source. So maybe because of that, because they wanted wider audience to cover everyone. Because if you are not giving open source, some of them won't use it. So it need a large amount of brain for it. Some of them are not using just because it is not free. I'm using ChatGPT previously because it was free completely, and they gave like limitations at point like you have to start a new chat, time limit, those things they gave. So, if I need to proceed with that, I have to buy the subscription for it, $20, $30, $50. I have to buy it. So they wanted wider audience, maybe because of that they just gave open source. And AI is a problem for anybody who are like anybody like it is going to take over the job. Yes, it is going to take over the job, but we have to evolve and we need to cut short the things that we were doing previously from scratch and proceed with something greater than AI, which we have now. Then it is fine. Yeah, then it is everything is fine. Whatever they are giving open source, we can make use of it. But what you are going to do with that? That is the
That
thing.
differs.
Yeah, if you're like using same old classification model again and again, what is the point? It will get ruled out. Everything. Yeah. So yeah.
Yes, now I think you can proceed to the demo.
Yeah, let's go with one simple addition thing that I tried with, and go with the scratch or something. So only one thing I'm going to use is random package. So here we want to train the model. So then only it will learn, right? You have to teach the model. So the teaching part is learning. I mean the training.
Yeah.
So we have to, if you know the neural network thing, we have something called weights. Weights is one which will tune your model, like the feedbacks or something that we give for it, like it is wrong. Take diversion, which we say, right? That is weights.
Yeah, I am little bit aware about of neural network, and so there are nodes and some stuff like that, right? And each of the nodes will have certain weights attached to it, and by that they will know what is the most preferred next node to s-
Yes.
get to the final destination. I think that's yeah.
Yeah. We're going to teach the model simple. That's all. Like we're not going to. There is no rocket science here so far.
Okay, so
So
we're going to teach AI how to assign those weights.
sorry, what was that?
We are going to teach a model that how to assign that weights to the needs of.
Weight is something that we give to make the model to learn. Learn in the sense like you have like four different directions. So just imagine like a baby is sitting and you're like going to teach that it is apple. You will say like apple means it will be red color and you will have like seeds in between that will be small. So those things you have to teach, right? So that is what the weights will do. So features is a different thing, but weights is something numbers that you're going to talk to a AI in numbers. You can't just give natural language to it. The weights will give you if it is a right answer or if it predicted more than above 50 percentage, it will carry more weightage like
Correct,
that.
correct.
Yes. So learning rate is the one which will give you the uh, you know uh, range, like till 3 years you can learn these things like that. It is there, no, like LKG, UKG.
Oh,
So 1 year is a learning rate to learn and move to next class.
yes.
That is your learning rate. Okay. So 0.1 and
So what does this 0.01 means here?
it's a range like it will take every step 0.01 steps.
Okay.
The range in the sense like it will learn and the alignment will happen. If you go with the formula, you will have a weight with your value. So we're going to give the model to have like two calculations like A and B, A plus B. For A, we gave weight 1, and for B, we gave weight 2. So it will be sum up. For that, we are setting a range of learning rate 0.01. So that much step is enough to understand the old summation and move to a next iteration. Iteration in the sense like all together. This calculation part is there, no? Like from weight, your input plus your weight to and another input. So these two will be combined with the learning rate 0.01.
Yep.
Yes. It helps to learn. Yeah. So production, okay, the auto, I'm using this, okay. So we'll change this input, one is as A so that we won't get confused. And
Yep.
okay, AI is everywhere. Things so that.
Yeah.
Mm, okay. Next, we are going with training. It's a whole code where we have the training function which the weights are defined as a global variable so that wherever we can just use directly for learning. And as I said, whenever there is a error in the sense bias, we say. So error is to tune your output whenever you get. So it is a simple neural network thing, and there is no, uh, a great logic, but it is sufficient to make your bot to understand what is addition. So let's just start with the model. Let it train for okay. So we started with 50 epochs in the beginning, and we just predicted 3 plus 2 as 5. That is true. Yes. So we are giving feedback for it. So it is true, right? Equal to 5 is true, and we don't have any error in here. And at last, we are giving like, is there any false in here? No. So it learned from it with the epochs of 500. So we have a AI which understand what is addition. So we can do whatever the addition operation within two variables, A and B, because we trained with that. If we give like plus C, it won't understand. So we have to feed those information for it so that it understands like, oh, okay, if we do that, it is like summation is something, any number that will be added together, and sum of that will be a final answer. So that is how this entire thing does. So yeah, any questions till now?
Not yet.
Okay, so it's a simple one, and it's a basic AI thing. All we need to do is like we have to, yeah.
Yeah. Can you explain if you can explain me what is epoch?
Okay, epochs is number of times it need to do this training. So you see this function, right?
Yep.
So it is like a for loop that we are mentioning with a range. It need to loop back again and again, right? That is your epoch. I have to train the model 500 times. So epoch is something which will give you like number of times, how many number of times it need to understand, it need to memorize. You getting right? Like for some human being, we can just ask it to 10 times to memorize a name. They can. For some people, it won't. Like that.
Okay, so for get to the for what I'm understanding here is, let's say for the first one where we took a is equals to 3 and b is equals to 2, for the machine, I mean for the AI, it took 50 trials get to the correct answer before.
Yes. Yes. Yeah.
Okay, and
So I didn't
next
want
one
to
is
start from 1, so I just started from 50. So at 50th iteration, it learned what is addition, like what two number with plus sign is.
okay.
Yeah.
Okay. And what is that last thing? Testing the AI. Okay, okay. So there after the
This
model.
testing is your the last thing that you do out of the input that you gave. Like you're going to test randomly, which I just gave like these many examples for it to test it. So for now, we just did the training with the limited version, which we gave by ourselves, like the training part. The testing will be like random things that we can think
Okay.
and give. So
Yep, yep.
yeah.
That means after the model is trained, we are trying to use it and we are trying to see if it is predicting the correct answer. Okay, so yeah, so while testing, we just perform one iteration. We just give the input and it will directly give us the expected output.
So
Thereafter,
this part is the testing part, which we are not using. So we just took the model which trained. So predict is our model. So we trained this and we just made it to understand what is this predict function is there. No, so we just made it to understand what is plus. I mean addition, sum, or any operation it is. So we just made it to understand. And whenever we use this, it will be able to do this operation. So that is what it is. This is your testing part. This is your model which we trained.
yeah, yeah.
Yeah.
Got it. This is,
You try with small pieces of AI. Okay, take time, and you build one. AI agent. This is also called an AI agent because it is going to help you to calculate something. A summation. We just taught it to understand what the summation is. So it will do any operation that you give for addition. So it is your AI. Yeah. So someone who's your assistant who can do the things that you're doing is your AI agent. That is your agent, right?
yep.
So you can build one simple agent where you can just go and teach a model what is what. You can use your LLM API or Gemini API that you have. You can use it and just teach what is what. Like you can ask a question or you can ask it to explain something. And end of the day, I mean, sorry, end of the session, you give the feedback for it, whether it gave your right answers or wrong answers or we
Oh,
can respond with good, bad, excellent,
correct.
like that. Just build one small thing. Use LLMs. I mean, Gemini or Claude, anything that you have, use it and try with that. Is one way of backend that how AI is learning. Okay, so yeah.
Correct. Yes, I think if that's the end of the session, I'll make sure to continue from here.
Yes, yes. So if you guys are like expecting to have the application, real-time application, which we were talking about as an AI agent, you can watch that full video in Enel's YouTube channel. So he'll be posting that the assignment which I gave now in his channel. So you can watch that. I'll give the link for his channel. So whenever feel free to ask some of the questions. I even post that in the community that we have, and you can find every resources that you wanted. So thanks everyone. Henel, you have any doubt or questions now? That's all right.
No, no, not now. I'll experiment on this code and I'll learn it. And yeah, I'll make a video on this one. And I would like to thank you for giving this session.
Yes. Sorry about it. So yeah, that's all, guys. Yeah, meet you all in next session. Thanks. Bye.